Hello guys, welcome back to SAP 2000 video tutorials. In this video tutorial, we will go through a RCC frame which will look like this. So if you see these four columns are in one direction and these four columns are in the other direction. So we'll draw a RCC frame looking something like this. Let me minimize this and maximize that. Okay, so I'll just go to file, I'll select new model, and in here I'll say 3D frames. You can even draw your own grid, or you can just go to 3D frames and uh, select the number of base in X, Y and Z direction, and it will automatically select your default beam and column section. But if you want, you can go to grid. You can say number of grid lines in X direction as 3, and number of, let me just check it out, how many do we need. Alright, 1 2 3 4 in X, in Y it will be 4, in Z let's make them 2. So this will be 4. Alright, let's make them 3 instead. 3 3 and alright 3. So I'll give in X direction 12 feet, in Y direction the spacing will be 12 feet, in Z direction let me keep it as 10 feet. The origin will be at 0 comma 0 comma 0. I'll select OK now. So now my 3D uh, like my 3D coordinate grid is created for me. And now first thing I'll do is I'll just go to define. I'll say section properties. In here I'll say frame sections. I'll define my, I'll say add new property, which will be a concrete, and first one will be, let's say beam 1. I'll give it as 18 inches by 18 inches. As you can see, my units are in feet, so I'll have 18 inches by 18 inches. I'll select. So coming over, next thing will be, so the next thing is like we can either design the reinforcement or we can provide reinforcement to be checked. So first what I'll do is I'll select this concrete reinforcement. I'll go in here. I'll select whatever grade of steel I want. I can even add new grade, like I can say add new material. I can say United States steel, and I can say grade 50 or whatever grade I want. Alright, so next thing is, since this is beam, I'll select beam over here, and the cover I'll be providing is, okay, let me just cancel this for now, and let me go over here and say inches first. Then I'll go to define. I'll say section properties. I'll follow the same usual procedure I told you guys. I'll add new property, rectangular 18 by 18 inches, and yeah, I'll add one more concrete, 5000 psi concrete. I can add over here 5000 psi. Now I'll go to concrete reinforcement. I'm not getting the, anyways, So I'll say over here reinforcement to be designed, so it will design the reinforcement on its own. It will give you the area of the reinforcement required, like 10 square per foot, something like that, square foot, something like that. So I'll make sure that I select beam over here, and my cover I'll keep it as 2 inches for now. Usually it varies, it can be 1.5 inches. I'll select OK. I'll select OK over here, and I'll just modify this property. I'll say beam 1, select OK. Now I'll add new property. I'll just say rectangular concrete section. I'll say let's keep a beam 2 also, just in case, which will be 24 by 18, and as usual beam we'll keep it as 2. Okay, I'll select OK for now. Now I'll add one more property, which will be column, and let's say I have it as 28 by 18, and it will be 5000 psi. I'll go to concrete reinforcement over here. I'll make sure that design type is column, my grade of steel being selected, my reinforcement the way I want my reinforcement, nothing but rectangular. As you can see, rectangular reinforcement, and the clear cover for confinement bars will be 1.5 inches. Total number of longitudinal bars along the 3 direction face, nothing but 3 over here and 3 in this direction also. The longitudinal bar size is 9, but this all doesn't matter until and unless you select reinforcement to be checked. For now we'll select reinforcement to be designed, and we'll select OK. We'll select OK for now. Okay, let me just modify this and say column 1, and I'll select OK. Okay, now that we are done with column, let me sorry, now that we are done with the section properties, let me go to load patterns, and let me add live load. So this will be the only loads for now. We can go to win loads and stuff in the next video tutorials, in the coming video tutorials. Alright, select OK. Now I'll go to load cases. There will be 3 load cases, that's fine. And I'll also go to load combinations. I'll say add default design combos. That will add my design combos as per the code. Concrete frame design, I'll select OK. So there will be 2 combinations. If you want, you can check them. See, 1.4 dead is one combination, then there will be 1.2 dead plus 1.6 live. Alright, that's good. Now coming to your grid. Now you can see this is the XY plane at 240 inches. Let me just change this to feet. So now it's at 20 feet, and let me go to 10 feet, I mean below it. I need to select this move down in list, so that it will select the bottom grid, which is at 10 feet. And I think I need, as per my drawing, I might need one more 1 2 and 3. I'll need one more, or will I need? No, I don't need it actually. So anyways, what I'll do is I'll just go to this draw framework cable, or I can go in draw framework cable or tendon command. I'll select from here to here to here to there to there to there and there. I'll give a right click. There you go. Now that you have created this, oh, I need one more. I need from here to here, right? So now one more thing is we have a cantilever. Let's say it's 3-foot cantilever on this side, and there's also a beam on this side, but we'll leave that beam for now. We'll just put this cantilever. So I'll just edit my grid data. Okay, there you go. You just need to select on, you just need to make sure you're on the grid and double click it like that. Okay, there also should be a command somewhere. I think let's in define grid data somewhere. Okay, over here, coordinate systems and grids. So we'll say modify show system. Then in here you can see we have 3 grids, 1 2 3 on this direction. So 1 2 3. So I'll just go and add 4th grid, and I'll say it will be -3. It will be primary, sorry, primary. I'll say show it, and yeah, that. And once that is done, I'll select OK. I'll select OK. Now you can see there's one more grid 4. I'll just use my frame command. I'll draw around it. I'll select escape. So whenever you draw using a frame command, you can see it over here that your beam 1 is selected as your section. So let it be for now. If you want, you can change it later on. I'll show you how to do that. And yeah, next we'll try to replicate these sections to look exactly on the top flow. So I'll go to edit, I'll say replicate, I'll make sure it's in Z direction, I'll say 10 feet, and I'll select OK. So as you can see, they are replicated very nicely. Now I can go to X, Z view, and I can come back to the first, nothing but grid number 4, and since I need columns over here, I'm gonna draw those. I'll just say over here it will be my column I'll select from here to here, and then from there to there. I'll give right click. I'll select again from here to here and here to here. I'll give right click. Now I'll select these two columns. I'll replicate those. First I'll go to edit, replicate. I'll say it will be in y direction, nothing but 3 feet. I'll select OK. Exactly 3 feet. Oh, I forgot to select. Oh my god. Alright, let me just say Ctrl Z. I'll select those again. I'll go to edit. I'll go to replicate. I'll remove this DZ because that moved my columns 10 feet above. I'll select OK now. So as you can see, they are replicated. I need more replications to be done, so I'll go to grid 1. I'll say move up. There you go. Now as we know, the x and y grids were spaced at 12 feet. We'll say replicate and 12 feet. I'll select OK, and then again I'll select those 4 columns. I'll go to replicate. I'll say 24 feet because we are at grid 1, and from grid 1 to grid 3 it will be 24 feet. I'll select OK. Alright, now we need columns over here. So what I'll do is I'll just go to YZ and I'll move up to grid number, sorry, I'll move down actually, so that I can move to grid number B, and I need 2 columns. So these are those columns. As you can see, I have selected those columns over here. It shows in the 3D view. Now I'll go to edit. I'll replicate those. I'll say 0 in Y and 12 in X, but I think this will be minus 12 because we are moving in the backward direction. I'll select OK for now. Now as you can see, your columns have been created. Okay, now once this is done, what we need to do is we'll just okay, let me just move this little bit this way so that I can select all the joint sections at the bottom, and I'll assign restraints as fixed over there. I'll select OK. So as you can see, all of them are fixed. Now coming to the loads, okay, let me just show you how to do the loads. So first thing I'll do is I'll select all the beams, nothing but I'll select lines parallel to coordinate axis or plane, and let me select the coordinate axis as X and Y so that all my beams are selected. Now I'll go to assign, I'll go to frame loads, I'll say distributed, and I'll add dead load of, let's say 6 PLF. So over here I'm just adding the loads to show how to add those, but in real life, in design of a real structure, you will have loads coming from the slab, from the wall, and the other loads that come on the beam and other loads also, other point loads also. So yeah, I'm just showing you like how to do this, and I'll select OK for now. So this dead load will be everything including the slab and stuff, but I know this, it won't be 6, it will be more than that, but I'm just adding that for now. I'll select OK. As you can see, my 6 PLF has been shown to me. Next I'll do is I'll go to select, I'll say previous selection, and I'll go to I'll go to assign frame loads distributed. I'll say I'll say distributed live load in gravity direction, and I'll keep it as 10 PLF. I'll select OK for now. You can see 10 PLF being added. Now once this is done, we are done with the loads, as you can see. And what I can do next is should I add any more loads? Alright, that's fine for now. I'll just go to run analysis, and I'll run now. Okay, I'll select my file name will be RCC frame 1. I'll select save, and the analysis will run in the background. Now you can see the deformed shape, and you can even see the animation of this shape. So this is a very fast animation. I'll just slow it down for you guys. As you can see, that will be the animation of the deformed shape. Anyways, I'll stop the animation, and let's go and see the forces. Let me do it for unconditional 2. I'll see the shear. I'll select filling diagram will be like this, and if I select show values, it will be that. Now you can see all these values are in pound feet. Let me just change them to keep pound feet. Alright, let me just select that one, and I just want to see how much load did we provide them. Anyways, so whatever the load might be, I just wanted to make sure that the load was keep feet in units. 6 KLF. I just wanted to make sure it was 6 KLF. Anyways, so you can see our shear, you can even see our moment diagram. There you go, your moments, and also you can design it, but before that I'm just going to unlock this and just make sure that my loads are not what I thought. Let me just change this to pounds feet. There. So okay, what I'm gonna do is I'm just gonna change the loads. I'll go to select, I'll try previous selection. No, it didn't work. Anyways, I'll go to select. Oops. I'll select lines parallel to coordinate axis, x, y should be fine. Select OK. I'll make sure that this is in keep feet. I'll go to assign. I'll say frame loads distributed dead. I'll select 6 KLF, and I'll make sure that in my options I have add to replace existing loads, so that it will replace the loads that were placed before this 6 KLF. I'll select OK. Now since you have selected this window, it's showing on this window. If you select this window, and if you say select to get previous selection, assign frame loads, distributed, I'll select live, and I'll give it as 10 KLF. I'll say replace existing loads, select OK. So now you can see the loads have been replaced. You can even select one beam and just right click it, and you can see in the loads tab that your load is 6k left dead and 10k left live. I'll select OK. Now I'll just run the model. Now you can find your shear stress and also moment diagram shown over here. So this is for live. I'll just select this window. I'll select conditional 2, that will include my 1.2 dead plus 1.6 live. There you go. Now once we are done with this, we'll just go to this tab which says start concrete design or check off structure, and we'll select a design combinations are this, that's fine. I'll select OK. The next thing I want is more. Okay, these are preferences, whatever the code you want. Like if you are for Indian code, then you just need to select an Indian code IS456 as you know it. Whatever the code it is, you select it. I'll select ACI 2009, and these values will be like automatically let me try for another code, automatically updated as per the code. Okay, fine, I'll select OK for now. Next thing I'll do is I'll just start concrete design and check off structure. Okay, now you can see looks like we are almost at 0.9 stress ratios. So if you see any one which is like this, like almost orangish color, you can just select that and right click it. So once you right click it, you can see your ratios. Let me cancel this. Let me go to here. I'll just go in here. Holy shit, display design info. I'll say I'll select repair percentage. I'll select OK. Now you can see the percentages get shown. Go to display design info again, and you can say column beam capacity ratios and select OK. So those looks very bad. Again, you can go to display design info, joint shear capacity ratios, select OK. Those are too bad. You can go and select longitudinal reinforcing for shear reinforcing actually. Alright, so there it looks like that. Anyways, we'll go in here, we'll say verify all members passed. So all concrete frames pass the stress capacity check or are designed. Now in order to see the area of rebar required, you just need to go to file, you need to create a report, and let's say it as frame 1. Sorry about that. And it should create you a new frame. It should create you a new frame notepad. It will have, this will have everything, all the contents like our structure and everything. If you go towards the end, you should be able to see areas required still. You see over there. And now that we are done with this, okay, next thing we'll try to do is, let me first unlock this. Now we'll provide the reinforcement and we'll make sure that it checks the reinforcement for us. So I'll just go to define my section properties, frame sections. I'll select beam 1, modify the show property. I'll go to concrete reinforcement. Okay, this looks good for me. I'll select in here, I'll select reinforcement to be checked. I'll reduce this number to numbers 8. Select OK. I'll select OK. I'll go to column, modifier show property. In concrete reinforcement, I'll select reinforcement to be checked, and column, I'll select OK. Select OK. Now that you're done with this, you just run the analysis. And I'll say start design of that structure. So as you can see, the values look so good to me. I mean, all the stress ratios are passing. Zero 0.056, that's good. I'll select that and I can see that there's a capacity ratio of 0.833. You can even find this other details that you want about it, but we'll learn about that later on. Anyways, so looks like my structure is over designed. Let me just go and unlock this and just change few of the stuff. I'll go to section properties, frame sections. I'll say column, modifier show property. I'll select it as number 7 just to show you that how it shows when it failed. I'll run the structure. Alright, so now as you can see, this failed. They are crossing the ratio of 1, all the columns almost. So in that case, I'll just go back to my section properties. So the best thing is, as you go back to section properties, frame sections, and change something in here, you don't need to go and select back all the members again and assign it again. It automatically changes the properties of that column. And run the analysis after changing the reinforcement. I'll check my concrete structure. You can see that's 0.454. Not bad. Not bad. Let me just go in here and verify all members has passed. Yeah, all concrete frames pass the stress capacity check or are designed. So guys, this is the way how you do a RCC frame. In coming tutorials, we'll also add a slab and we'll do wind load analysis, earthquake analysis. All those videos will be coming up. Please keep watching and subscribe. Thank you guys for watching the video.